everyone. I'm Diego, the Developer Advocate here at Scaleway, and I'm joined today here at AI Pulse by two very interesting attendees. Would you guys mind to introduce yourselves?
Certainly. My name is Tom Vaughan. I'm a staff technologist at the CommCraw Foundation. I specialize in big data and open data sets. And yeah.
I'm Pedro Ortiz. I am a researcher at the FKI, although I'm technically here on holidays passing by. So, yeah, I've been also working for a while with big data sets and specifically with CommCraw data.
What a nice way to spend your holidays, just attending an AI conference.
Yeah.
Love it.
Talking
That's
about
great.
data. Yeah.
So we were just having a conversation about large language models and what they actually are, right? So what's a language model? Would you define that for someone who is not an experienced AI researcher or developer?
ELI 5.
Do you want to answer that or you want me to?
You'd probably be more qualified to answer that question.
Let me see. To somebody that is not a researcher in this.
Yeah,
so,
me.
Okay, I would say it's just how would I define it? Very simply. So it's a ML model, so machine learning model. That what it is effectively doing is just trying to predict the next word. So how it works, maybe how it works is a good explanation of what it is. So how it works is just a neural network. And what we are going to do to train that neural network is we are going to take a very big data set, like for instance, crawl data from the internet. So this is web page text from web pages. And what we are going to do is extract the interesting text. So these are going to be like articles with titles and long paragraphs. And then we are going to fit all of this to this very, very large neural network. And we are going to train it to predict the next word. So you are literally reading, let's say, this article word by word. And what you're asking the neural network to do is just to, given the context, so given, let's say, these 5 words, predict the next one. And then you do this until you complete the paragraph. And this is everything that this neural network is doing.
Right. So you're just jumping into a large part. You need a large amount of data.
Yes. So there's something in this, well, in our field called these scaling laws. And how they work is literally so, I mean, it's not exactly that, but let's say the more neurons, or like the specific term is parameters, so the more parameters your neural network has, the more data you need to actually train it. So what we have been seeing in latest years is that both the data sets that we are using to train these models and the size of these models in parameters, and I mean, when I say the size in parameters, I also mean the size in the infrastructure that you need to both train it and run it afterwards when it's trained. So this is scale it. So when you scale the parameters and the infrastructure, you also need to scale the amount of data that you feed to the models. So to give you an example, with the first language models, we were training, let's call it the not so large language models. We were training them with just something like Wikipedia, the text from Wikipedia. And right now we are using whole snapshots of the internet to train them along books, along scientific articles, along, I don't know, newspapers, dictionaries, all the text that you can find.
And what's the actual benefit I get as a user, as an implementator of these models, when I jump from one small model that was trained with data from Wikipedia and this huge model that you just mentioned?
So in a way, it's going to be like a more general model in a way. So what the user is going to see is that the model becomes more capable. So capable of solving certain tasks or solving certain problems. This is, I mean, I would say it's a debate to a certain extent. Like, why is it? It's maybe because of the data or maybe because of the model size. I would say it's because of both, because in order to read, or let's say in order to um, learn in a way that amount of data, you need a large model. So when you have both a large model trained with a large data set, you're going to have a lot of different kinds of domains, a lot of different kinds of topics, a lot of different kinds of things that are covered on that data set. And your model is going to become way more capable of, I don't know, things like arithmetic, things like recipes. So for instance, you're not going to find those many recipes in Wikipedia. Or if, I don't know, you want your LLM to write an email for you, you are not going to find that, let's say, template for the email that you want to write on Wikipedia. So as we scale both the size of the model and the data set, we also make the model way more general purpose.
All right, so it understands and it's better capable of handling more contexts.
Yeah.
Then why do I need to fine tune my model afterwards?
Okay, so I mean, as I said in the beginning, what the model is effectively doing is just it's like the autocomplete from your keyboard on your phone. It's just that it's a much larger model trained with way more data. But the problem is that, I mean, back in the day when we were fine-tuning these models were for specific tasks, specific applications. Today, when we talk about fine-tuning, is like instruction fine-tuning, dialogue fine-tuning. So we want our model to follow instructions, or we want our model to be capable of dialogue. So here what we are trying to do is, like, first we have, let's call it the base model, which is going to just autocomplete, like generate the next token or the next word. So what is going to happen then? Like, for instance, these models are going to be capable of doing things like arithmetic. So, but the thing is that you are not going to be capable of like querying these models by instructions. So if you say, what's 5 plus 5? Maybe in the data set there was like multiple questions about arithmetic, so it's not going to answer how much is 5 plus 5. Is going to come up with another question that was somewhere on the data set. So it's going to say what's 5 plus 5, and then it's going to autocomplete another was 6 plus 6, was 7 plus 7. So it's just going to autocomplete the sequence. So right now when we talk about things like fine-tuning, instruction fine-tuning, and dialogue fine-tuning, what we are effectively doing is we are taking this general purpose model and then we are giving it a set of instructions with answers. And the model is going to be fine-tuned to, instead of auto-completing a sequence of text, is going to auto-complete an instruction with an answer. So that's more or less why you need to still fine-tune these models.
Great. Now coming back to the size of data, so you mentioned the example of Wikipedia, but yeah, you need a large amount of data, way bigger than that. And we have huge models nowadays. Do all of these models need to basically query the whole world and base of knowledge of the world each time? Like, for instance, Bloom, did it have to start from scratch querying every single piece of data? Or is there a base model that these foundational models are using?
Okay, that's an interesting question. So there are multiple things. So I mean, in general, it is difficult right now. I think it's difficult to like work. Like if you want your model to do something specific, and you have a lot of resources, like you're a big company with lots of GPUs and you want to have your own model, I think it's better to actually train it yourself if you do have the resources instead of taking an existing model. The reason is that there are multiple, let's say, technical decisions that you can make when you train your model from scratch, and that is probably going to benefit your use case. So to give you an example, I mean, we cannot feed raw text just like this to a model. So we have to do something which is called tokenization, in which we have words and we have to split them. If you take an existing general model that was trained with general text, for instance, it's going to work very well with general text, but let's say with scientific text, it's going to be not very good. This is because it has never seen formulas, and the tokenizer is going to be very bad at tokenizing formulas, like, let's say, mathematical formulas. So if you want to work with scientific text, I don't know, you're a startup working with scientific articles, doing ontologies or whatever, something like this, you probably want to train your model from scratch, and you want to train it with in the domain that you want your model to perform well. So this is valid for the topic discussion, like here, like for instance, the domain is scientific domain, but it also, I would say it's also a valid discussion when you are talking about going from one language to another. So we still have lots of limitations of saying, like, I have my English model, and that's already trained, and I want to use that English model in French, for instance.
Right. So when it comes to actually getting that data, what's the whole process?
I think he can.
Because yeah, you just, I don't know, query every single website in a bash script.
Kind of, yeah.
Everything's bash scripts, right?
Everything's a bash script, yeah. On its face, that's what crawling is. When you crawl the internet, you're taking a snapshot of what the internet looks like at a certain time. The company I represent is CommCraw, and we do a monthly crawl of the internet, and our data
Like
set is
the internet.
Yeah, the internet, the wider internet. Yeah, very, very large amount of the internet, big percentage of it. I don't actually know the specifics of how large a percentage of the internet it is. Pedro, who uses our data set, might be able to...
How do you measure the size of the internet?
That's a complicated question. I think...
Give us a simple answer.
I have seen estimates, and it was around 30-something% of the internet. For a given month. But I would say it depends on what's your definition of the internet also, because...
I think the web is a more helpful phrase to use. The distinction being...
Why is that?
The web is the layer on top of the internet, so that we have the internet's stack, right? So the web is the layer on top that serves hypertext,
right?
which is what is used to extract the data that's fed into LLMs. I mean, it's also like you have to take in account that, like for instance, CommCraw is not going to have, or whatever crawl is normally not going to have access to private data that's also on the web and on the internet, because lots of things, like even honestly, like today, like when you're visiting a news website, most of the, not most, but let's say some of those news websites today, they require subscriptions.
Yeah.
So that's data that you're not going to have normally in a crawl.
Yeah, that stuff won't be crawled. Yeah, the stuff that is crawled is the stuff that is deliberately publicly available, and yeah, it's the stuff that is deliberately made available to people, made public. So if it exists, if somebody's published something on the internet, then it stands to reason that they want it to be seen by people, and they don't mind if people use it for the purposes such as large language model training, but some other purposes of people's usage of CommCraw's data set is stuff like open data, open web search, and things of that nature. So the phrase we use is the democratization of data, so that it puts large amounts of data in the hands of people who would not have traditionally been able to use it. So certain large companies, like the Googles of the world, have got the resources to have enormous amounts of data at their fingertips, but traditionally there hasn't been a way for independent researchers or small companies to access that kind of volume of data. And CommCraw was started by a chap by the name of Gil Elbaz, who made a company that basically it was acquired by Google. It was the fifth acquisition by Google, I think, which essentially turned into AdSense.
Okay.
What became AdSense. And Gil's original vision for the company was so that, the little guy could start to use this large amount of data in the same way as multi-billion-dollar multinational conglomerates are. So it's about the freedom of usage of data for broadest sense. So people who are independent researchers can have the same opportunities.
Right. Regarding that, what if I, as an author of a website, don't want my website to be part of these huge sets of data? Is there a keyword that I can use on my robots.txt file, or
Yes, there is.
Okay.
Yeah, that's a very good question. Yes, you mentioned robots.txt, the robots exclusion protocol, which is that's what people can use to tell web crawl bots like ours and many others that they don't want their content to be crawled. You can have more granular control of that stuff, so that you can say, I don't want any crawler bots to crawl any of my sites. So you can, if you look up the robots exclusion protocol, you can find the directives to put in that file that says, I don't want my website to be used by any crawl bots.
Right.
But there is a large amount of thinking being done and work that's being done on how to standardize the process for saying, I don't want my data to be used just in the context of AI or machine learning.
And there should be an RFC for that?
Yeah, I think actually that would be very helpful. And the point in an RFC really is that it's about a collaboration. It's about an ongoing conversation between people whose interests are many and varied, rather than the interests of one particular body.
Right. Now, on the other hand, what if I do want my website content to be crawled and to be used for these reasons? What would you recommend? Good semantics?
Yes. Yeah, proper usage of web standards, really. You don't actually need to do anything to your robots document to make it so that everything is allowed. You can do what we did at CommCraw, which is to put in a little Easter egg saying, we like robots, feel free to crawl our stuff. But you don't actually have to do anything. So it is very much it's currently an opt-out type arrangement.
All right.
But yeah, as you said, good semantics, proper usage of certain web standards. We were talking earlier on about the usage of text formatting and the appropriate usage of things like Unicode, UTF-8.
Yeah. Because I'm guessing there's going to be a heavy process of getting only the actual content of the website and just skipping the menus and the footers and all the non-content stuff, right?
So I guess that's more on the direction of like using the like using the data to train AI models or ML models, like large language models. So the answer is yes, but CommCraw does not provide this directly. So CommCraw now comes in two formats. One is, well, technically 3, but normally people train in LLMs either use the work format, which is all the HTML with the menus and everything, and the second one,
work being a web archive. Right?
exactly.
All right.
And the other one is the wet format, which is
It's the web page extraction, wet, I think. Extracted text.
Yes, I think
web
it's extracted text.
Yeah.
So it's literally just getting rid of all the HTML around the text and just downloading the text. The only problem when you do this, so I've been personally working for a while in like developing data sets to train large language models. Well, I actually have an open source project called Oscar that I started at INRIA when I was doing my PhD, and that I continue to maintain both with the collaboration with INRIA and now with the FKI. And the idea of that project is that we created a pipeline that is going to take this wet format from CommCraw, and what it's going to do is like automatically try to detect like, okay, are there, like in this text extract, are there still remains of, I don't know, the menus, the footers at the end, the headers, and also things that you might not want to put into your LLM. So we try to like reduce, not filter out, but actually not reduce. We try to annotate because like we just do an annotation of CommCraw. We don't filter content. We let the people actually training the LLM make the choosing.
Right.
So what we do is we try to annotate like, okay, is this probably adult content or harmful content that's undesirable for training LLMs? Is this, I don't know, a text that's like a website that it's only a list? There are many of those on the internet, so like probably you don't want your LLM spitting out list of URLs. That's not very useful. Or is it just like very short snippets of text that maybe you you don't want your LLM to be trained on that either. Like from experience, honestly, participating in projects like, I don't know, first the not so big language models like BERT, so I participated in the training of Camembert, the French model. And then in one of the LLMs, Bloom as well, I was part of that project. So I can tell you that you, in general, want like, let's say, clean, high-quality text, and this in general means like no lists, no tags, mostly things with long paragraphs.
All right.
Like what's desirable is long paragraphs, and then also try to get rid of certain topics that you don't want, especially if you're training generative language models, you don't want your LLM repeating certain things. So so yeah, so you can try to create like a pipeline to ingest all the data from CommCraw and then try to annotate it so that you can choose the documents that you're interested in.
Amazing. All right, guys. Thank you so much for sharing your knowledge, and I hope you continue enjoying the conference.
Thank you for having us.
Thank you.